Imagine asking one of the world's most advanced artificial intelligence systems a question that has fascinated humanity for centuries. What if aliens have secretly lived among us for the last 10,000 years? Most people would expect a simple answer: yes or no. Instead, the response opened the door to one of the most intriguing thought experiments ever discussed. Rather than claiming hidden knowledge, the AI explored how such an extraordinary idea could be examined through history, archaeology, biology, and human civilization. The result was unexpected, not because it proved aliens were here, but because it challenged the way we think about evidence, history, and the unknown. The AI began by pointing out an important fact. There is currently no verified scientific evidence that extraterrestrials have ever lived on Earth. Every credible scientific investigation into the question has reached the same conclusion. Extraordinary claims require extraordinary evidence. But instead of ending the discussion there, the AI proposed a hypothetical scenario. If an advanced civilization had wanted to observe humanity for thousands of years without revealing itself, how might it accomplish that mission? According to the thought experiment, the first rule would be simple: never interfere openly. Any civilization capable of traveling between stars would almost certainly understand that revealing itself too early could permanently alter the natural development of another intelligent species. Human history has shown countless examples of technologically advanced civilizations dramatically changing less advanced societies after first contact. If extraterrestrials understood this pattern, they might choose observation over interaction. The AI then examined the timeline. 10,000 years ago, humans were transitioning from hunter-gatherer lifestyles to early farming communities. Villages were growing larger, permanent settlements were beginning to appear. Civilization itself was still in its infancy. If an outside intelligence had wanted to observe humanity from the beginning of organized society, this period would represent a logical starting point. The next question was even more interesting. Would such visitors need enormous spacecraft hovering above cities? The AI suggested probably not. Truly advanced technology would likely be subtle rather than dramatic. Instead of giant machines attracting attention, observers might rely on methods that leave almost no trace at all. Miniaturized technology, autonomous systems, remote monitoring, or methods beyond current human understanding could theoretically allow long-term observation without obvious detection. The discussion then shifted toward history. Across thousands of years, nearly every civilization has recorded mysterious lights in the sky, strange visitors, unusual beings, or unexplained events. Ancient Egyptian texts describe celestial phenomena. Greek writers recorded mysterious objects. Roman historians occasionally mentioned unusual lights moving across the heavens. Medieval chronicles include reports of... Still, the AI admitted that archaeology continues uncovering surprises every year. Lost cities emerge beneath forests, buried civilizations reshape historical timelines. Unknown cultures are identified through satellite imagery and advanced scanning technologies. Human history remains incomplete, meaning future discoveries could continue changing our understanding of the past. That uncertainty, however, should not be confused with evidence of extraterrestrial involvement. The conversation became even more fascinating when the AI explored biology. If aliens had truly lived among humans for thousands of years, would they resemble us? Evolution suggests that intelligent life developing on another world would almost certainly follow a different biological path. Now, the odds of an unrelated species looking exactly human appear extremely small. Unless advanced technology allowed perfect disguise or genetic modification, remaining unnoticed for 10 millennia would present enormous challenges. The AI also discussed culture. Human civilizations developed countless languages, religions, traditions, and political systems independently across the globe. If hidden extraterrestrials had been secretly guiding humanity, researchers might expect evidence of coordinated influence across civilizations. Instead, history reveals remarkable diversity, frequent disagreement, and independent innovation. This pattern fits natural human development more closely than centralized external control. Perhaps the most unexpected part of the answer involved psychology rather than astronomy. The AI suggested that humanity has always been attracted to hidden explanations because mysteries capture attention. When evidence is incomplete, the human mind naturally searches for larger stories connecting isolated facts. This tendency fuels myths, legends, conspiracies, and imaginative speculation. It is part of human curiosity, one of the very qualities that drives scientific discovery. Finally, the AI reached its conclusion. If aliens had truly lived among us for 10,000 years while remaining completely undetected, they would have accomplished something extraordinary. Yet extraordinary secrecy is not evidence that such a civilization exists. At present, the most scientifically responsible position remains that there is no verified proof of long-term extraterrestrial presence on Earth. The real mystery is not whether hidden aliens have shaped our past, but how much of our own history remains waiting to be discovered. Every archaeological excavation, every space mission, every scientific breakthrough, and every new observation expands humanity's understanding of the universe. Until compelling evidence appears, the question remains one of imagination rather than established fact. But it is precisely questions like these that continue inspiring people to explore the unknown. The discussion did not end with the AI's conclusion. Instead, researchers posed another hypothetical question. If there were no verified evidence that extraterrestrials had lived among humans for 10,000 years, what kinds of evidence would scientists actually expect to find if such an extraordinary claim were ever true? The AI responded that the first step would not be searching for mysterious stories or unexplained legends. It would begin with physical evidence that could be independently examined, tested, and reproduced by researchers around the world. Science advances through observations that anyone can verify, not through claims that cannot be investigated. The AI explained that one possible category of evidence would involve materials unlike anything naturally produced on Earth. Such materials would need to possess measurable characteristics that could not be explained by known geological or industrial processes. Scientists would analyze their chemical composition, atomic structure, isotopic ratios, and manufacturing patterns. If every laboratory reached the same conclusion that the material could not have originated through known natural or human methods, researchers would have an important mystery worth investigating further. However, no such universally accepted material currently exists. Another possibility would involve unmistakable biological evidence. If an intelligent non-human species had lived alongside humanity for thousands of years, there would likely be biological traces distinguishable from every known terrestrial organism. DNA, proteins, cellular structures, or other biological markers would need to demonstrate characteristics fundamentally different from all life that evolved on Earth. The AI emphasized that modern genetics has revolutionized biology, allowing scientists to compare genomes across countless species with remarkable precision. So far, every confirmed organism examined belongs to Earth's shared evolutionary history. The conversation then shifted toward archaeology. The AI noted that archaeology frequently surprises researchers by revealing forgotten civilizations, lost cities, and unexpected technologies developed by ancient societies. Yet every genuine archaeological discovery becomes stronger through careful documentation, excavation, dating techniques, and peer review. Extraordinary discoveries are not accepted because they are exciting. They become accepted because evidence repeatedly supports the same conclusion. The scientific process protects history from speculation while allowing genuine breakthroughs to reshape understanding when justified. Researchers then asked whether ancient myths could contain memories of real encounters with something unusual. The AI acknowledged that myths often preserve fragments of cultural memory, natural disasters, astronomical observations, or symbolic explanations of the world. Flood narratives, celestial events, and mysterious beings appear across many civilizations. However, similarities between stories do not automatically establish a common extraterrestrial origin. Human societies frequently develop comparable narratives because they face similar natural phenomena, ask similar philosophical questions, and rely on storytelling to transmit knowledge across generations. Attention soon turned toward the night sky itself. Humanity has always looked upward with curiosity. Thousands of stars are visible without telescopes, while modern observatories reveal billions of galaxies spread across the observable universe. The sheer scale of the cosmos raises an obvious question. If intelligent life exists elsewhere, where is it? The AI explained that this question forms the basis of one of astronomy's most famous scientific discussions, often referred to as the search for extraterrestrial intelligence. Researchers continue scanning the universe for unusual radio signals, optical pulses, atmospheric signatures on distant planets, and other possible indicators of technological civilizations. Despite decades of searching, no confirmed detection has yet been made. The AI then explored another hypothetical scenario. Suppose an advanced civilization deliberately avoided broadcasting its presence. Such a civilization might recognize that transmitting powerful signals across space could reveal its location to unknown observers. In that case, silence might represent caution rather than absence. The researchers noted that this possibility could never be ruled out entirely, but neither could it be confirmed without evidence. The distinction between possibility and proof remained central throughout the discussion. As the interview continued, scientists asked how humanity should respond if convincing evidence of extraterrestrial intelligence were discovered tomorrow. The AI emphasized that the response should be guided by international scientific cooperation rather than fear or speculation. Independent laboratories would examine the evidence, multiple observatories would attempt confirmation. Governments, universities, and scientific organizations would compare findings openly. Transparency would become essential because discoveries affecting all humanity require global verification rather than isolated conclusions. The discussion also highlighted the importance of critical thinking. Throughout history, many remarkable claims have attracted enormous public attention before eventually receiving ordinary explanations. Unusual photographs have been traced to camera artifacts. Strange lights have been identified as atmospheric phenomena, satellites, rockets, or aircraft. Archaeological mysteries have often been solved through improved excavation techniques and better historical understanding. The AI argued that skepticism should not discourage curiosity. Instead, skepticism ensures that curiosity leads toward reliable knowledge rather than unsupported conclusions. Researchers then asked whether advanced artificial intelligence itself might someday help answer questions about extraterrestrial life. The AI suggested that machine learning could analyze enormous astronomical datasets far more quickly than human researchers working alone. AI systems already assist in identifying exoplanets, classifying galaxies, detecting unusual cosmic signals, and modeling complex physical systems. Future improvements could accelerate discoveries by recognizing subtle patterns that humans might overlook. Even so, AI-generated hypotheses would still require observational confirmation before becoming accepted science. The conversation concluded by returning to the original question. Had aliens lived among humanity for 10,000 years? The AI stated that no verified scientific evidence currently supports that claim. Nevertheless, the question remains valuable because it encourages exploration of astronomy, archaeology, biology, history, and the scientific method itself. Wonder and evidence are not opponents. Wonder inspires questions, while evidence determines which answers withstand careful examination. As the interview ended, one final message appeared on the screen. The universe is vast enough to inspire endless curiosity. The greatest discoveries begin with questions, but they are completed through evidence. Rather than offering certainty where none exists, the AI encouraged a mindset shared by generations of scientists. Remain curious, examine the facts carefully, welcome new evidence, and never stop exploring the unknown. The following week, the researchers returned with a new question that shifted the entire discussion in an unexpected direction. Instead of asking whether extraterrestrials had secretly lived among humanity, they asked what humanity itself might overlook if it searched only for dramatic evidence. The AI paused before generating its response. It explained that history often teaches a simple lesson. The greatest discoveries are rarely hidden because someone wanted them concealed. More often, they remain unnoticed because people are asking the wrong questions. The AI suggested imagining an archaeological site buried beneath thousands of years of sediment. Generations could walk directly above it without realizing what lay beneath their feet. The evidence would exist, yet it would remain invisible until someone developed the right tools, asked the right questions, and examined the right location. Science advances in exactly this way. New instruments frequently reveal realities that previous generations could not observe, not because those realities suddenly appeared, but because human understanding improved. The researchers considered whether this principle might apply to the search for intelligent life elsewhere in the universe. Modern astronomy has transformed dramatically during the past few decades. Powerful space telescopes now identify planets orbiting distant stars, analyze the chemical composition of alien atmospheres, and detect faint signals that earlier observatories could never have measured. Every technological leap expands humanity's ability to investigate questions once considered impossible. One scientist then posed another hypothetical question. If an advanced civilization wished to remain unnoticed, would humanity even recognize the evidence if it appeared today? The AI responded carefully. It explained that intelligence should never be measured only by technological capability. Truly advanced civilizations, if they exist, might prioritize efficiency, sustainability, or subtlety rather than spectacular displays. Human expectations often assume that advanced technology must appear dramatic. History repeatedly demonstrates the opposite. Many of humanity's greatest innovations became smaller, quieter, and more efficient over time. The discussion soon shifted toward communication. Humanity has spent decades searching for artificial radio signals from deep space. While this remains an important scientific effort, the AI noted that radio communication represents only one possible technology among countless possibilities. Human civilization itself has steadily reduced its dependence on powerful radio transmissions as communication methods evolved. Future civilizations might use technologies entirely unknown to modern science. If so, humanity could be searching the sky for signals that no advanced civilization uses anymore. That possibility fascinated the research team. It did not prove anything, but it reminded them how easily assumptions can shape scientific investigations. Every search begins with expectations, and expectations sometimes limit discovery. Remaining open to alternative possibilities while demanding strong evidence remains one of science's greatest strengths. The AI then returned to archaeology. It explained that ancient civilizations continue surprising researchers. Every year, remote sensing technologies reveal hidden cities beneath forests, deserts, and agricultural land. Sophisticated scanning systems detect structures invisible from the surface. These discoveries demonstrate that human history remains incomplete. Entire chapters of civilization have yet to be fully understood. This uncertainty should inspire further exploration rather than unsupported conclusions. The researchers agreed. Genuine mysteries still exist throughout human history. Lost settlements, undeciphered inscriptions, unexplained engineering techniques, and incomplete historical records continue challenging archaeologists. Solving these puzzles requires patience, careful investigation, and collaboration across multiple scientific disciplines. Each discovery contributes another piece to humanity's remarkably complex story. Attention then turned toward the psychology of belief. Why are people so captivated by hidden civilizations and extraterrestrial mysteries? The AI explained that uncertainty naturally attracts imagination. Human beings evolve by recognizing patterns, anticipating danger, and constructing explanations for unfamiliar events. These abilities contributed greatly to survival. However, they also encourage people to connect unrelated observations into larger narratives. Critical thinking helps distinguish genuine patterns from coincidental ones. One researcher observed that curiosity itself remains one of humanity's greatest strengths. Without curiosity, astronomy would never have developed. Archaeology would never uncover ancient cultures. Biology would never reveal life's complexity. Exploration begins with questions that initially seem impossible to answer. The challenge lies in allowing evidence rather than assumptions to determine which answers ultimately survive. As the conversation continued, the AI proposed an unexpected perspective. Perhaps the most important question is not whether hidden extraterrestrials exist on Earth today. Perhaps the more meaningful question is whether humanity is prepared to recognize extraordinary evidence if it ever appears. Scientific revolutions often encounter resistance because they challenge deeply established ideas. Yet genuine evidence eventually changes understanding regardless of previous expectations. The researchers appreciated this distinction. Science neither accepts nor rejects extraordinary claims based solely on popularity. Instead, it evaluates evidence using consistent standards. This process sometimes produces surprising conclusions. Other times, it demonstrates that fascinating ideas lack sufficient support. Either outcome contributes to knowledge because both rely upon careful investigation. The discussion eventually expanded beyond Earth itself. Thousands of confirmed exoplanets now orbit distant stars. Some exist within regions where liquid water might be possible under suitable conditions. Future observatories may detect atmospheric gases associated with biological activity. While such observations would not automatically confirm intelligent life, they could significantly reshape humanity's understanding of life's distribution throughout the cosmos. The AI emphasized that astronomy is entering a remarkable period. Instruments scheduled for deployment during the coming decades may examine distant planetary atmospheres with unprecedented precision. Researchers hope to identify combinations of gases difficult to explain through geology alone. Such findings would represent important scientific milestones, though additional investigation would always remain necessary before drawing extraordinary conclusions. Toward the end of the session, one participant asked what lesson future generations might learn from humanity's ongoing search for extraterrestrial life. The AI answered that the search itself already possesses tremendous value regardless of its outcome. Developing better telescopes advances engineering. Studying planetary atmospheres improves climate science. Investigating biology beyond Earth deepens understanding of life on our own planet. Even unsuccessful searches expand knowledge by eliminating possibilities and refining future investigations. The researchers concluded that perhaps humanity sometimes focuses too heavily on dramatic revelations while overlooking quieter achievements. Every improved observation, every archaeological discovery, every technological innovation, and every carefully tested hypothesis gradually expands humanity's understanding of reality. Progress rarely arrives through a single astonishing moment. More often, it emerges through thousands of careful observations accumulated over many years. As the final question appeared, the room grew quiet. What is the greatest mystery facing humanity today? The AI responded that the universe contains countless unanswered questions. The origin of consciousness, the nature of dark matter, the behavior of black holes, the possibility of life beyond Earth, and the future of intelligent civilizations all remain active areas of scientific investigation. Rather than fearing unanswered questions, humanity should celebrate them. Every mystery represents an invitation to explore, to learn, and to discover. The screen displayed one final sentence before the session ended. The unknown should inspire careful investigation, not unquestioned certainty. Curiosity opens the door. Evidence decides what lies beyond it. The researchers left the room recognizing that the discussion had not produced proof of hidden extraterrestrials. Instead, it had offered something arguably more valuable. A reminder that genuine discovery depends on curiosity guided by evidence. Whether humanity someday finds life elsewhere in the universe or learns that intelligent civilizations are exceedingly rare, the journey of exploration will continue. Each observation, each experiment, and each question brings humanity one step closer to understanding its place in a universe that remains far larger and more mysterious than anyone fully imagined. The research team gathered once again, but this time the conversation took a different direction. Instead of asking whether hidden extraterrestrials existed, they asked a broader question that challenged the limits of human understanding. If humanity were someday to discover undeniable evidence of intelligent life beyond Earth, what would change first? The AI explained that the greatest transformation would probably not occur in technology or politics. It would begin in the human mind. For thousands of years, civilizations have viewed themselves as the central actors in history. Confirming intelligent life elsewhere would immediately expand humanity's perspective, forcing every generation to reconsider its place within the universe. The AI explained that history offers many examples of discoveries that fundamentally changed how people understood reality. Ancient civilizations once believed the Earth occupied the center of everything. Later observations demonstrated that our planet travels around the Sun. Centuries afterward, astronomers learned that the Sun itself is only one ordinary star among hundreds of billions within the Milky Way. Modern astronomy has since revealed that our galaxy is merely one of billions throughout the observable universe. Every major discovery has made humanity realize that reality is larger and more complex than previously imagined. One researcher wondered whether first contact, if it ever occurred, would resemble the dramatic scenes often portrayed in movies. The AI suggested that reality would likely be far less theatrical and far more scientific. Initial evidence might come from a telescope detecting an unmistakably artificial signal, an observatory identifying a technological signature on a distant planet, or a spacecraft discovering compelling biological evidence within our own solar system. Such discoveries would unfold through careful verification rather than sudden announcements. The discussion then focused on how scientists verify extraordinary discoveries. The AI emphasized that every important claim passes through rigorous examination before being accepted. Independent teams repeat observations, compare measurements, test alternative explanations, and challenge one another's conclusions. This process is sometimes slow, but it protects science from mistakes and ensures that major discoveries rest upon reliable evidence. Curiosity begins the journey, but verification determines the destination. Another participant asked why humanity remains so fascinated with hidden civilizations and mysterious visitors. The AI explained that unanswered questions naturally attract attention because the human brain evolved to seek explanations. Throughout history, people have looked toward unfamiliar phenomena and imagined possibilities extending beyond ordinary experience. This imagination has inspired myths, literature, philosophy, scientific exploration, and technological innovation. While imagination alone cannot establish truth, it often motivates the questions that eventually lead to genuine discoveries. The researchers shifted their attention toward the search for life within our own solar system. Mars continues attracting scientific interest because evidence suggests that liquid water existed there billions of years ago. The icy moons Europa and Enceladus contain oceans beneath frozen surfaces, making them compelling targets for future exploration. Scientists also continue investigating Titan, whose complex chemistry may offer valuable insights into the conditions necessary for life. The AI explained that these missions represent practical, evidence-based approaches to one of humanity's greatest questions. The conversation eventually turned toward artificial intelligence itself. One researcher asked whether future AI systems might become essential partners in scientific discovery. The AI responded that advanced computational systems already assist researchers by analyzing enormous quantities of astronomical data, identifying unusual patterns, modeling planetary atmospheres, and processing observations collected by telescopes around the world. As technology improves, AI will likely become an increasingly valuable scientific tool, but it will remain dependent upon observational evidence rather than speculation. Attention soon returned to the importance of asking better questions. The AI argued that scientific progress often accelerates when researchers redefine the questions they are attempting to answer. Instead of asking whether hidden visitors secretly influenced history, scientists may learn more by asking how life begins, how intelligence evolves, how civilizations survive over immense periods, and how detectable technological societies might become across cosmic distances. These questions produce measurable investigations capable of generating reliable knowledge. One astronomer observed that humanity has entered an extraordinary era of exploration. Space telescopes now identify distant planets with remarkable precision. Robotic spacecraft continue examining worlds throughout the solar system. Planetary missions gather chemical data that previous generations could scarcely imagine obtaining. Future observatories may one day detect atmospheric combinations, strongly suggesting biological activity on planets orbiting distant stars. Such achievements demonstrate how rapidly scientific capability continues advancing. The AI emphasized that genuine scientific mysteries remain abundant. Dark matter, dark energy, the origin of consciousness, the emergence of complex life, and the evolution of intelligent civilizations all remain subjects of active investigation. Rather than diminishing wonder, scientific understanding often reveals even deeper questions waiting to be explored. Every answer uncovers additional mysteries beyond it. One participant reflected on the role of patience in discovery. History demonstrates that meaningful breakthroughs frequently require decades of careful observation, technological innovation, and international collaboration. Great discoveries rarely appear overnight. Instead, they emerge through countless incremental advances achieved by scientists working across generations. The AI agreed, explaining that patience remains one of the defining characteristics of successful scientific inquiry. As the discussion neared its conclusion, the researchers asked one final question. What should humanity do while waiting for definitive evidence regarding life beyond Earth? The AI answered that the best path forward is continued exploration, build better telescopes, launch more ambitious spacecraft, study the origins of life, protect scientific integrity, encourage curiosity while demanding evidence. Every mission, every experiment, and every observation contributes to humanity's understanding, regardless of whether extraterrestrial intelligence is ultimately discovered. The room remained silent for several moments after the final response appeared. The researchers realized that the conversation had never truly been about proving hidden aliens. It had been about something much larger. Humanity's greatest strength is not possessing every answer. It is the willingness to continue asking questions, improving methods, and following evidence wherever it leads. Before ending the session, the AI displayed one last statement across the screen. The universe rewards curiosity, but it reveals its secrets only to those willing to test every idea against evidence. No one in the room interpreted the sentence as the conclusion of the mystery. Instead, they recognized it as the beginning of another chapter in humanity's ongoing search to understand a universe that remains vast, beautiful, and filled with unanswered questions. Whether intelligent life exists elsewhere or not, the pursuit of that answer continues inspiring science, exploration, and discovery. In that pursuit, the greatest adventure may not be finding someone else among the stars. It may be learning more about ourselves as we continue reaching toward them.